Hello, I'm Maruk Said, your microbiology guide. Let's explore in-depth micro techniques and uncover groundbreaking insight together on this educational journey into the fascinating realms of microbes.
Understanding microbial spoilage in canned food. Causes and prevention explained. Table of contents. Introduction to microbial spoilage of canned foods. Spoilage of canned food and its causes. Spoilage by spore-forming thermophilic bacteria. Spoilage by mesophilic spore-forming bacteria. Spoilage by non-spore-forming bacteria. Spoilage by yeast and mold. Preservation of canned food from microbial spoilage. What is canning? Steps of canning. Introduction to microbial spoilage of canned foods. Microbial spoilage of canned foods is influenced by the pH level of the food. Based on pH, canned foods can be categorized as follows. Low-acid canned foods, pH greater than 5.2, include meat products, milk, dairy products, and seafood. Acid canned foods, pH 4.5 and 3.7, include tomatoes, pears, figs, oranges, apricots, pineapples, etc. High-acid canned foods, pH less than 3.7, include pickled products, fermented products, ketchup, jams, jellies, etc. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Spoilage of canned food and its causes. First, physical damage leading to spoilage. Physical damage can result in microbial or chemical spoilage due to the following reasons. Scheduled process not delivered because of mechanical or personnel failure. Improperly or inadequately formed seals, seams. Defective containers or defective lids of the containers. Overfilling of the food. Second, chemical spoilages. Chemical spoilage may occur due to storage temperature, acidity of food, reaction between food and metal cans, insufficient exhausting during canning, presence of soluble sulfur and phosphorus in food, enzymatic action of food. These factors can lead to swelling of cans, discoloration of food, off flavors in food, corrosion of metal cans leading to loss of nutritive quality, cloudiness observed in syrups, brine, or gravy. Third, microbial spoilages. Microbial spoilage occurs due to survival of spores of thermophilic bacteria, growth of these bacteria due to inadequate cooling, insufficient heat treatment, or improper storage temperature, recontamination of microorganisms due to can leakage, microbial spoilage of canned foods and its preservation. Spoilage by spore-forming thermophilic bacteria. First, flat sour spoilage. Flat sour spoilage causes sourness in the product due to acid production from carbohydrates without swelling of the can. It occurs only in low-acid foods and acid foods, caused by the germination and growth of facultative anaerobic bacteria, such as Geobacillus styrothermophilus, Bacillus coagulans, Bacillus thermoexciderans, and Geobacillus styrothermophilus. Sources of these organisms include plant equipment, sugar, starch, and soil. Second, thermophilic anaerobic spoilage, caused by anaerobic bacteria such as Thermoanaerobacter and Thermoanerobacterium, e.g., Clostridium thermosaccharolyticum, produces hydrogen and carbon dioxide gases. Sour fermentation occurs at high temperatures in medium-acid canned foods. The gases cause can swelling, sometimes leading to bursting of the can, often results in a butyric or cheesy odor in the food. Occurs due to slow cooling or storage at high temperatures, hot storage. Third, thermophilic anaerobic sulfide spoilage, caused by gram-negative obligate anaerobic spore formers such as Disulphotomaculum nigrificans, Clostridium bifermentans, and Clostridium sporogenes in low-acid canned foods. Produces hydrogen sulfide, causing a rotten egg odor without can swelling. Hydrogen sulfide reacts with food to form iron sulfide, leading to black coloration of food and the interior of cans. Occurs due to underprocessing, slow cooling, or hot storage. Spoilage by mesophilic spore-forming bacteria. First, spoilage by mesophilic Clostridium species. Several Clostridium species, such as Clostridium butyricum and Clostridium pasteurianum, can survive in low-acid canned foods and cause spoilage. These organisms ferment carbohydrates to produce volatile acids like butyric acid and generate hydrogen and carbon dioxide gases, resulting in can swelling. Proteolytic species such as Clostridium sporogenes, Clostridium putrefaciens, and Clostridium botulinum also spoil canned foods. These bacteria metabolize proteins and release foul-smelling compounds such as hydrogen sulfide, mercaptans, indoles, and ammonia. Inadequate heat treatment allows the survival of mesophilic Clostridium species. Second, spoilage by mesophilic bacillus species. Mesophilic Bacillus subtilis and Bacillus mesentericus cause spoilage in low-acid canned foods. Spoilage commonly occurs in poorly evacuated cans. Insufficient heat treatment permits survival of mesophilic bacillus species. Bacillus polymixa and Bacillus macarons also lead to spoilage due to can leakage. Spoilage by non-spore-forming bacteria. Non-spore-forming bacteria can survive in canned food due to mild heat treatments, such as pasteurization or from can leakage. Thermoduric non-spore formers include Enterococcus, Enterococcus faecalis, and Enterococcus faecium, Microbacterium, Streptococcus thermophilus, Micrococcus, and Lactobacillus. Acid-forming Lactobacillus species may survive under processed canned foods. These bacteria produce carbon dioxide, causing can swelling. Other spoilage-causing bacteria in leaked cans include Pseudomonas, Alcaligenes, Micrococcus, Flavobacterium, Proteus, and others. Spoilage by yeast and mold. The presence of yeast and mold in canned foods indicates issues such as underprocessing, leakage, recontamination, or poor evacuation. Fermentative yeasts produce carbon dioxide, which leads to swelling of the can. Yeasts commonly grow on the surface of high-acid foods, including pickled products. Torulopsis lactis and Torulopsis globosa cause blowing or gaseous spoilage in sweetened condensed milk, especially when it is not heat processed. Torulopsis stellata causes spoilage in canned lemon and can grow at a low pH of 2.5. Mold species such as Aspergillus, Basoclamus, Penicillium, and Citromyces are frequently found in canned foods with high sugar content, 70 to 72%. Mold spoilage of canned food is recognized by moldy taste, unpleasant odor, color fading, presence of mold mycelia, and occasionally slight swelling of the container. Types of canned food spoilage based on acidity, causes and resulting defects in cans and food products. Low-acid canned food, pH greater than 5.2. Examples: meat and meat products, milk, dairy items, seafood. Cause: thermophilic flat sour bacteria, Geobacillus stereothermophilus, Bacillus coagulans. Canned defects: flat, no gas formation, altered vacuum. Product defects: lowered pH, sour taste, off odor and off flavor, occasionally cloudy juice. Examples: corn, peas. Cause: sulfide-producing anaerobes, Clostridium nigrificans, Clostridium bifermentans, Desulfotomaculum nigrificans. Canned defects: flat, hydrogen sulfide absorbed by the food. Product defects: blackening of food, rotten egg odor, iron sulfide precipitate. Examples: corn, spinach. Cause: Mesophilic putrefactive anaerobic bacteria, Clostridium botulinum. Canned defects: swelling, possible bursting due to gas production. Product defects: partial digestion, increased pH, putrid odor, production of ammonia, indoles, carbon dioxide, hydrogen, and hydrogen sulfide. Acid canned food, pH 4.5 and 3.7. Examples: tomatoes, pears, figs, oranges, apricots, pineapples. Cause: Mesophilic spore formers, Bacillus polymixa, Bacillus macarons, Clostridium pastorianum. Canned defects: flat or swollen. Product defects: coagulation, gas, and acid production. Cause: butyric anaerobes, Clostridium butyricum, Clostridium tertium. Canned defects: swollen, may burst. Product defects: fermentation, gas production, carbon dioxide, hydrogen, butyric, rancid odor. Cause: aciduric bacteria, Geobacillus stereothermophilus, Bacillus coagulans. Canned defects: flat, no gas formation, altered vacuum. Product defects: lowered pH, souring, off odor and flavor, occasionally cloudy juice. High acid canned food, pH less than 3.7. Examples: pickled and fermented products, ketchup, jams, jellies, marmalades, fruits in syrup, fruit butters. Cause: yeasts, Saccharomyces, Zygosaccharomyces. Canned defects: swelling, bursting, or leakage due to gas production. Product defects: fermentation, hydrogen formation, and yeasty odor. Cause: molds, Bisochlomus fulva, Aspergillus, Penicillium, Citromyces. Canned defects: swelling, bursting, or leakage due to gas formation. Product defects: fermentation, carbon dioxide production, and moldy, chaju yeasty odor. Cause: lactic acid bacteria, Lactobacillus brevis, Lactobacillus mesentericus, Lactobacillus dextranicum, Lactobacillus mobilis. Canned defects: swelling, possible bursting, or halted swelling. Product defects: acidic odor, ropiness, and formation of carbon dioxide and acids. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Preservation of canned food from microbial spoilage. Canned foods undergo thermal processing to achieve commercial sterility, allowing for extended shelf life under storage conditions. Although canning is a heat-based preservation method, it does not guarantee complete protection from microbial spoilage. Recontamination may still occur due to various factors post-processing. To effectively prevent microbial spoilage and maintain the nutritional quality of canned foods, additional preservation methods can be used in combination with canning to further extend shelf life. 1. Radiation. Radiation sterilization, also known as radapertization, involves exposing sealed canned foods to ionizing radiation to eliminate spoilage microorganisms. This method is particularly effective for disinfecting the surfaces of jars and lids used in canning. 2. Preservatives agents. Preservatives are compounds that inhibit or slow down the growth of microbes and are often classified as generally recognized as safe. Examples include organic acids, sulfites, ethylene oxide, sodium nitrite, ethyl formate, lactic acid bacteria, and bacteriocins. 3. Chilling storage. Storing canned foods at low temperatures, 0–5 degrees Celsius, helps reduce microbial growth and enzymatic activity. This cooling significantly extends the shelf life and maintains the quality of canned food products. What is canning? Canning is a food preservation technique in which food is processed and sealed in an airtight container, such as metal cans, glass jars, plastic containers, thermostable plastics, or multi-layered flexible pouches. This method is also known as appertization, named after its inventor, Nicholas Appert. Canning is an effective way to extend the shelf life of food products for a prolonged period. The primary goal of applying heat during canning is to destroy harmful pathogens and spoilage microorganisms. The airtight seal of the container prevents any new microorganisms from contaminating the food. Steps of canning. 1. Preparations. The containers intended for filling are preheated for sterilization. The preparation of food depends on its type and typically includes processes like washing, trimming, sorting, grading, peeling, cutting, dicing, slicing, segmenting, pitting, and blanching. 2. Filling in the containers. The prepared food is filled into sterilized containers. The container is then filled with hot solutions such as sugar syrup or fruit juices, brine with spices for vegetables, or gravy for meats. This step adds flavor, preservatives, assists in further sterilization, and helps remove air spaces. 3. Exhausting. Exhausting refers to the process of removing air from the container before sealing. This step helps prevent excessive pressure and strain during sterilization. It prevents the bulging of cans and minimizes the chemical reactions between the container and food. 4. Sealing. After exhausting, the containers are immediately sealed. Different types of sealing methods are used depending on the product, such as screw-type or crown capping machines for glass jars and bottles, or dielectric or conduction heating for plastic pouches. It is crucial that the temperature of the canned food is not below 74 degrees Celsius during sealing. 5. Processing of the can. The sealed cans are heat-treated immediately after sealing at the appropriate temperature and time. The goal is to eliminate microorganisms and their spores without affecting the food's nutritional quality. Heat is typically applied at temperatures above 100 degrees Celsius. Vegetative bacteria are killed at 80 degrees Celsius for 30 minutes. Spore-forming microorganisms at 110 degrees Celsius for 30 minutes, and spores are destroyed at 121 degrees Celsius for 3 minutes. 6. Container cooling. After processing, the cans are rapidly cooled to room temperature. This can be done by immersing the hot cans in cold water or by spraying them with jets of cold water. 7. Labeling and storage. After cooling, the outer surface of the cans is dried for labeling. The label includes product identification, brand name, net content by weight or volume, code number, processor's name and address, ingredients, nutritional information, manufacture date, and expiry date. After labeling, the cans are stored in cool and dry places until they are ready for dispatch. Thank you so much for watching. Don't forget to subscribe to my channel, press the bell icon button. Thank you!